Well, I have a few more tools to develop, so humor me. Pulling out a nifty piece of scratch paper. Now look carefully at what I said earlier. dy dx, or shall I say the derivative of that with respect to x, is the derivative of that with respect to t over dx dt, period. So, to find a way I can actually compute the second derivative, notice that this is the derivative with respect to x of this. But derivative of something with respect to x is the ratio of two things. The thing downstairs is just dx dt. The thing upstairs is the derivative of that with respect to t. Well, that is just simply y prime. So in the end, my second derivative can be interpreted as the ratio of the derivative of y prime with respect to t to dx dt. So let's see if you and I can't, I don't know, discuss concavity. On my last example, I still have it on the other side of this board. So to talk about concavity, looks to me like I'm going to need dy dt, and I don't remember what it was, so let me recompute it. I think I misspoke. I need dy dx, not dy dt. So first things first, dy dx, which is y prime, isn't that just simply dy dt over dx dt? But I just showed that the second derivative for y with respect to x can be interpreted as this. Now, here's my y prime. To differentiate it, I'll use the quotient rule. And I'll divide by dx dt. But dx dt is this. Now here's my long division bar. So when I invert and multiply, that throws an extra factor downstairs. So I get this cubed. And I think likewise, I'm going to get upstairs, whatever this mess is. That could give me cheaper 6 minus 12. Let me just double check the arithmetic. I like it. Okay. So is that going to give me 6 minus 12 is negative 6? So everyone, check out what this really says. It says I have no zeros in my numerator, but I do have 2 zeros in my denominator. But again, I'm running out of room. I don't want to get rid of the picture. How about just the first 2 lines? Okay. So if you allow me to talk about concavity, I will draw a number line. Plot the only 2 zeros I have downstairs. With those 2 real numbers, subdivide the real number line into 3 subintervals. I'll check those intervals for the sign of my concavity. So the sign of my second derivative, if t is bigger than this, is clearly negative. I clearly change because of odd power, and then change again because of odd power. So it looks to me like my sine graph suggesting that I change from concave down to concave up to concave down about those 2 interesting values of t. And let's just see if that's true in the picture. So concave down if t is less than negative 1 over root 3, but here's the point I get at the t value. Notice that this curve portion of the curve is indeed concave down because I'm living below my tangent lines, locally speaking. Now, concavity is in the upward direction between these 2 t values, but these 2 t values in blue are here and here, and notice how the curve is concave up, because at any given point, my curve lives, locally speaking, above my tangent line. And then lastly, concave down from t there on up to infinity. Yes, that holds true. So from here to here, I'm concave down, because again, my curve is locally speaking below its tangent lines, except of course, at the point of tangency, it shares that point. Well, one more tool in our back pocket. We still have 2 more to go.